Welcome. In this video, we're going to determine whether the series shown here converges or diverges using the ratio test. The first thing you want to do is identify a sub n, and this is a sub n right here. And we need this because we want to figure out what a sub n plus 1 is. And what we're doing is we're setting up to make a ratio. So a sub n plus 1 is negative 1 to the n plus 1 power times n plus 1 squared over 2. And if you notice, everywhere I had an n, I just replaced with an n plus 1. So this n here became n plus 1. So this nth power here will become an n plus 1 power. And the whole idea is we're setting up to evaluate this limit. We're letting this limit L equal the limit as n approaches infinity of the absolute value of the next term divided by the previous term. And so long as it's less than 1, the series converges absolutely. If L is greater than 1, it diverges, and of course if L equals 1, then this test is inconclusive. All right, now let's go ahead and work on this limit. So the limit as n approaches infinity of the next term, that's the nth plus 1 term divided by the nth term, that's equal to the limit as n approaches infinity. In our numerator, we have negative 1 to the n plus 1 power times n plus 1 squared divided by 2 to the n plus 1. And in our denominator, we have negative 1 to the nth power times n squared divided by 2 to the n. And this is, of course, all within an absolute value. And this is L. We can simplify this a bit to be n, I forgot my limit notation. The limit as n approaches infinity of n plus 1 squared over 2 to the n plus 1 times 2 to the n over n squared. Now, if you're wondering what happened to those negatives in the absolute value, just notice that whether or not this ratio is a negative 1 over a positive 1 or positive 1 over negative 1, all negatives, all positive, the absolute value will ensure it's positive. All right, let's keep going. This is equal to the limit as n approaches infinity of 1/2 times n plus 1 over n squared. This is just done using rules of exponents here for this one. And this uses the property that if we have a quotient raised to the same power, we can just have the quotient all raised to that power. Okay, so this is 1/2 times the limit as n approaches infinity of 1 plus 1 over n quantity squared. Now, as n grows large, this will go to 0, and we're really just left with 1/2 times 1, which is 1/2. Now, this tells us, since 1/2 is less than 1, this is the number 1, not an I, not an L, it's a number 1. Since it's less than 1, we're in this case here, and the series converges absolutely by the ratio test. I hope you found this video livelier than a giddy child in a candy store.